Hi everyone, and welcome to our brand new playlist on real analysis. Whether you're currently a student taking a course in real analysis, or you're trying to learn real analysis on your own, or maybe you're just simply curious about the foundations that make calculus rigorous, well, you're in the right place. Real analysis is a branch of mathematics that gives a solid foundation to calculus. It is a rigorous study of the set of real numbers and functions defined on subsets of the real numbers. Instead of taking concepts like limits, continuity, derivatives, and even major theorems like the intermediate value theorem for granted, we will actually build them from the ground up using logic, proofs, and careful definitions. So this will be an introductory course to real analysis, and my goal is to present the big ideas of the subject in a very rigorous and precise way, but also making them accessible and easy to understand to as many people as possible. I want to help you gain confidence with proof writing, improve your logical reasoning, and develop an appreciation for the structure underlying calculus. I find the subject of real analysis very interesting. The arguments and proofs in analysis reveal very deep and elegant logic that can be actually very satisfying when you understand it properly. And so we will begin our journey by studying the set of real numbers. We will look at what these numbers are, what makes them so special, and how they're different from other sets of numbers, like for example, the set of rational numbers. Next, we will dive into sequences and series, and this is a very important chapter. Understanding what it means for a sequence to converge is absolutely essential for the rest of the course. After that, we will cover the basic topology of the real number line, and you've probably heard of open and closed intervals, but we will look deeper into open and closed intervals, and we will also see what other kinds of subsets the real numbers can have. Then comes limits and continuity. We will define what it actually means for a function to approach a limit and what makes a function continuous. Next up, we will talk about derivatives. We will revisit your favorite differentiation rules, and we will also get into theorems like the mean value theorem and the intermediate value theorem and see why they matter. Then we will return to sequences and series, but this time of functions, not numbers. And finally, we will wrap things up with the Riemann integral, a rigorous approach to defining the area under a curve. Throughout this series, I'll follow the structure of the book Understanding Analysis by Stephen Abbott. In my opinion, it's a very well-written book with very clear explanations and good exercises. So if you're looking for a textbook to follow along or dive a little bit deeper, then this is the one I would recommend. Also, many university courses also use this book. So if your course happens to follow it, then that's even better. Let's get started with the very first lesson, in which we discuss how the discovery of a single number led to the need for the set of real numbers. Thanks for watching. If you enjoyed this video or found it helpful, I would really appreciate it if you could like the video and subscribe for more content. And if you have any questions or thoughts, feel free to leave a comment down below. I would love to hear from you.